So the third theorem is called the triangle bisector theorem. And with this one, you're going to deal with the angle being bisected. So here's triangle ABC. And triangles have 3 angles, obviously, but we only are going to bisect one. So if it's the one at the top, great. If it's angle A and we bisect it, then it cuts it exactly in half. You have whatever this measurement is and whatever this measurement is, okay? It creates a third or a third point down here at the bottom. We'll call it D, okay? This theorem says that if the angles created are congruent to each other, so angle BAD, if it's congruent to the other angle, CAD, meaning it's perfectly bisected, then we're going to have another proportion. Okay? That proportion is going to be your left side and your right side. And it's going to be what we're going to call the outer and the bottom, and the outer and the bottom. Okay? So for the left side, the outer is this AB, and the bottom is this BB. That's the left side of the bisected triangle. And then on the right side of your proportion, you're going to go outer to bottom as well. So the outer is AC, and the bottom is DC. Right? So you can see that there's going to be four spots. 3 of them are going to have numbers. 1 of them's going to have a missing piece, and you're going to fill that in. All right, let's try it with some numbers plugged in. This is going to be example number 3. Okay. Tricky part on example number 3, I'm going to bisect angle Q. So here's the angle that's bisected, and you're probably going to have these little arcs to show which one's bisected, and then you're going to realize this one is upside down. Okay. Let's fill in some measurements. We've got 32 meters over here. We've got x minus 2 here, x plus 5 here, and 40 meters over here. Okay, so if it's upside down and I go to do my imaginary line, instead of this being my left, this is actually my right side, and this is actually my left side. So if I'm like upside down, okay, this is the outer, and this is the bottom. This is the outer, and this is the bottom. So when I set up my proportion, and this is how you should always start. Do your fraction equal to a fraction. Draw your stuff, and then fill in your pieces of information. So on the left side, you're going to do your outer, which is 40, over your bottom, which is x plus 5. So 40 over x plus 5. And then on the right side, you're going to have your outer, which is 32, over your bottom, which is x minus 2. And then you're just going to solve your proportion like you've been getting good at. Okay, so notice it doesn't really matter which way to go first because you're going to have a variable on both sides. So let's go 40 times x minus 2 first. Set that equal to 32 times the x plus 5. That means I need to distribute on both sides as my first step. So 40 times x is 40x. 40 times negative 2 is negative 80. On the right, 32 times x is 32x. And 32 times 5, I got 160. I have variables on both sides, so I need to move it to one side or the other. So I look for the smaller one, and this one's smaller. So I'm going to subtract 32x from both sides. In the same step, I'm going to add the 80 to move that over here. These are opposites, and then we're going to combine what's left. So 40x minus 32x is 8x, and 160 plus 80 is 240. And then the inverse operation of multiplying by 8 is dividing both sides by 8. So I got x is equal to 30. Okay. If the problem just asks you to solve for x, you're done. Every once in a while it'll say, okay, what is, oh, if we put an s right here, what is PS? Or what is RS? Yeah, just plug it back in. Okay. So for PS, you're going to have 30 minus 2, which is 28. And this one was in meters. And then RS is going to be 30 plus 5, which is 35. Notice that these two answers are not the same because the two sides are not the same. They're actually a perfect ratio to each other. Okay? All right, finish copying that down, and then